In 1963, a 28-year-old designer ignored his father's advice, dismissed every safety engineer's recommendation, and bet Porsche's future on placing the engine in the worst possible location. Ferdinand Alexander Porsche, called Butzi by everyone who knew him, chose the rear engine layout for the 911, and that single decision would define 6 decades of automotive obsession. You're looking at engineering's most beautiful mistake. The Porsche 911 shouldn't exist, not with its engine hanging behind the rear axle like a wrecking ball waiting to swing. Ferry Porsche, Butzi's father, and the company's managing director, wanted the engine up front. He'd seen the lawsuits from 356 crashes, read the accident reports, understood the physics that made rear-engine cars punish even small mistakes with spectacular spins. But Butzi held firm. The engine stayed in the back, and Porsche committed to solving a problem that sensible engineers simply avoided. If Porsche had listened to conventional wisdom in 1963, the 911 would handle like a Corvette, predictable, safe, and utterly forgettable. Instead, they created a car that required you to learn its language, to understand weight transfer and throttle steering, to become part of the machine rather than just pointing it down the road. This is the story of how wrong became right, how a compromise became an identity, and how refusing to fix a fundamental flaw turned into Porsche's greatest competitive advantage. And it starts decades before Butzi ever picked up a pencil, with his grandfather's determination to put engines where they didn't belong. Ferdinand Porsche, the elder, the legend, the man who would eventually design the Volkswagen Beetle, spent his career obsessed with rear-engine layouts. He believed in putting the weight over the driven wheels, convinced that traction trumped everything else engineers worried about. In 1934, he sketched a streamlined car with the engine behind a rear axle for Auto Union's Grand Prix program. 3 years later, he applied the same philosophy to the KDF wagon, the people's car, that would become the Beetle. The Porsche company itself emerged from this obsession. When Ferry Porsche built the first car bearing the family name in 1948, he mounted the engine in the back, just like his father had taught him. The 356 used a modified Volkswagen Flat 4, air-cooled, producing just 40 PS in its original form. Ferry positioned it behind the rear axle, creating the layout that would define Porsche for the next 7 decades. But by the late 1950s, Ferry Porsche understood the problem. The 356's handling was, to put it diplomatically, demanding. Lift off the throttle mid-quarter in a 356, and the weight transfer would rotate the car faster than most drivers could react. Insurance companies noticed the pattern in accident reports. Rear-engine Porsches featured prominently in single-vehicle crashes where drivers simply lost control. Ferry began seriously considering a front-engine layout for the 356's successor. He commissioned studies, talked to engineers, examined what Mercedes-Benz and BMW were doing with their sports cars. The SL class from Mercedes had its engine up front, as did BMW's upcoming 1500 sedan program. The entire industry seemed to agree. Modern sports cars needed balanced weight distribution, and that meant the engine between the axles or in front. Ferry even looked at the Corvette's layout as a potential template. Chevrolet had launched the C2 Stingray in 1963 with a front-mounted V8 and independent rear suspension, exactly the configuration Ferry thought Porsche needed. But Ferry hadn't counted on his son's stubbornness. Butzi Porsche had joined the family company in 1957 after studying industrial design at the Ulm School of Design. He'd been sketching sports cars since childhood, and he knew exactly what shape the next Porsche should take. That shape required the engine in the back. Butzi's design philosophy centered on proportion and recognizability. He wanted a car you could identify from 100 meters away, a silhouette that couldn't be mistaken for anything else on the road. The sloping rear deck of the 356, that distinctive fastback profile created by the rear-mounted engine, that was Porsche's visual signature. Move the engine forward, and he'd need to redesign everything, creating something that looked like every other sports car from Italy or Britain. The design sessions in Zuffenhausen became tense. Ferry pushed for front-engine practicality. Butzi defended the rear engine layout with sketches showing how the proportions would collapse if they moved the drivetrain. Other voices joined the debate. Helmuth Bott, Porsche's chief engineer, calculated weight distributions and center of gravity positions. The numbers favored a front-engine design, or at minimum, a mid-engine layout with the power plant ahead of the rear axle. But Butzi won the argument through sheer persistence and the power of his father's trust. In 1962, Ferry approved the rear-engine layout for what was then called the 901 project. The decision carried massive risk. Porsche was tiny in 1962, producing fewer than 8,000 cars annually, surviving on 356 sales and engineering contracts with other manufacturers. Committing to a rear-engine sports car meant betting the company on the assumption that engineers could solve problems that physics said were fundamental. It meant accepting that the 901 would be harder to drive fast than its competitors, hoping that difficulty would translate to engagement rather than frustration. The engineering team, led by Ferdinand, Ferry's nephew and another member of the dynasty, took the challenge seriously. They couldn't change the weight distribution, so they have to change everything else. The 901 prototype that rolled out in 1963 featured a completely new flat-six engine, air-cooled, producing 130 PS from 2 liters. Porsche positioned it as forward as packaging allowed, but it still hung entirely behind the rear axle. The suspension received the most attention. Traditional sports cars use simple configurations, double wishbones up front, a live axle or swing axles in the back. Porsche developed a sophisticated McPherson strut arrangement for the front, giving them precise control over camber and caster angles during compression and rebound. These angles determined how the tire contacted the road surface during cornering, crucial for a car that already had compromised front-end grip due to lack of weight. The McPherson strut design used a single damper unit combining the spring and shock absorber, mounted at an angle that allowed engineers to program specific geometric changes. As the wheel moved up and down, the strut's angle changed the wheel's relationship to the road surface in ways that traditional double wishbones couldn't achieve as efficiently. This was critical for the 911's unique challenge. With only 38% of the car's weight over the front axle at rest, Porsche needed maximum grip from the front tires during quartering. The McPherson strut geometry could maintain negative camber through compression, keeping the tire's contact patch flat on the road even as body roll tried to lift the inside edge. The engineering team tested dozens of spring rates and damper settings at Porsche's proving grounds. They discovered that softer front springs actually improved balance by allowing more weight transfer to the front during turn-in, giving the driver more front-end grip when initiating a corner. But soft springs alone created their own problems. The car would dive excessively under braking and pitch during acceleration, behaviors that felt unstable and reduced driver confidence. Porsche's solution was to use progressive rate springs that stiffened as they compressed, offering compliance for small bumps while preventing excessive body motion during hard driving. In the rear, they initially used semi-trailing arms, a design where each wheel moved independently on an arm angled between lateral and longitudinal. This setup reduced the violent camber changes that plagued swing axle designs like the Beetle's, though it couldn't eliminate the fundamental issue of weight transfer. Porsche's engineers added another element, careful spring and damper tuning that tried to manage how weight shifted during acceleration, braking, and quartering. They couldn't prevent the physics, but they could soften the transitions. The Frankfurt Motor Show in September 1963 gave the automotive world its first look at what Porsche had created. The 901 debuted to mixed reactions. Design critics loved the proportions, that long hood, the sloping roofline flowing into the fastback rear, the distinctive round headlights. The shape looked organic, purposeful, unlike the angular designs coming from Italy or the rounded curves of British roadsters. Engineering publications questioned the rear engine layout. Road and Track's European correspondent wondered why Porsche insisted on perpetuating a configuration that created the oversteer characteristics that give inexperienced drivers trouble. Then Peugeot complained. The French automaker held trademark rights to three-digit model numbers with 0 in the middle, used across their entire range. Porsche changed the name to 911, keeping the project's internal designation while avoiding legal conflict. The production version went on sale in September 1964 as a 1965 model. Early reviews confirmed every fear Ferry Porsche had expressed during those design meetings. The 911 was spectacular to drive near the limit, but getting there required technique that most sports car buyers didn't possess. Car and Driver's technical editor described the transition from understeer to oversteer as sudden enough to be startling. The magazine recorded 0 to 100 km per hour, acceleration at 8.5 seconds, respectable for a 2-liter engine producing 130 PS, but the handling demanded attention. Lift abruptly off the throttle while cornering, and the 911's rear end would step out as weight transferred forward, unloading the rear tires just when you needed them most. The pendulum effect of that rear-mounted engine, all that mass behind the pivot point, amplified every mistake. Porsche's test drivers developed techniques to manage the behavior, trail braking into corners, maintaining throttle mid-corner, using small steering inputs. These became the skills that separated 911 drivers from 911 owners. But the complaints kept coming. Insurance companies raised rates on 911s after noting higher accident rates compared to front-engine sports cars. Driving schools began warning students about the unique characteristics of rear-engine Porsches. Ferry Porsche watched this unfold with the grim satisfaction of being proven right. He commissioned a study in 1966 examining whether Porsche should develop a front-engine sports car alongside or eventually replacing the 911. The business case looked compelling. Mercedes-Benz had just launched the 230 SL, a refined Grand Tourer with the engine up front, priced similarly to the 911. Sales were strong, reviews glowing. BMW was developing the 2000 CS Coupe, another front-engine design targeting the same premium sports car market. Even Jaguar's E-Type, considered by many the most beautiful sports car ever made, had its engine conventionally placed ahead of the driver. Porsche's engineers proposed Project 914, a mid-engine layout that would place the power plant ahead of the rear axle, improving weight distribution while maintaining the compact dimensions that made Porsche special. Ferry approved limited development work. But something unexpected happened that changed the entire trajectory. Customers didn't care about the engineering criticism. 911 sales climbed steadily through the late 1960s. Buyers weren't intimidated by the challenging handling. They were intrigued by it. The car developed a cult following among enthusiasts who appreciated the requirement to learn its personality. Porsche sold 2,935 units of the 911 in 1965, the first full production year. By 1967, that number reached 4,865, despite price increases and continued handling warnings in automotive press. The 911 attracted a specific type of buyer, someone who wanted engagement over ease, who saw the demanding nature as a feature rather than a flaw. These customers talked about the 911 like a relationship that required work but rewarded commitment. Racing proved the concept could work at the highest level. Porsche prepared a 911 for the 1965 Monte Carlo Rally, fitting it with modified suspension and weight distribution adjustments. Herbert Ling and Peter Falk drove the car to 5th overall, ahead of larger-engined competitors. The result silenced some critics. If the layout could work in rallying, where surfaces change constantly and mistakes mean sliding into trees, maybe the engineering wasn't as compromised as everyone assumed. That Monte Carlo result came despite significant disadvantages. The 911's rear engine layout made it tail-happy on the ice and snow stages that dominated the rally. Traditional front-engine rally cars could use their forward weight bias to maintain steering control even when sliding. The Porsche discovered an unexpected advantage. On dry tarmac sections, particularly tight mountain roads with hairpin turns, the 911's rear weight gave exceptional traction during acceleration out of corners. Where front-engine cars would spin their wheels fighting for grip, the 911 simply hooked up and pulled. This pattern would repeat throughout the 911's competition history. The car was difficult in low-traction situations, but dominant when grip was available. Porsche's engineers began optimizing specifically for this characteristic, rather than fighting it. For 1966, Porsche entered multiple 911s in various European rallies, using competition as a development laboratory. The feedback from professional drivers, men like Vic Elford and Poli Toivonen, who'd driven everything, gave engineers real-world data about how the rear-engine layout behaved under extreme conditions. Elford's feedback was particularly valuable. He explained how the 911 required different techniques than conventional cars, later braking because the rear weight helped stability, earlier throttle application to use weight transfer constructively, and maintaining momentum through fast quarters rather than slowing and accelerating. These techniques, refined on rally stages and racetracks, filtered back to Porsche's development team. They realized that instead of trying to make the 911 drive like a conventional car, they should optimize it for drivers who'd learned its unique physics. Porsche doubled down on development. For the 1967 model year, they introduced the 911S with 160 PS from the same 2-liter flat six, achieved through higher compression, improved breathing, and revised camshafts. The S also received Porsche's first attempt at addressing the handling balance: front and rear anti-roll bars, stiffer springs, Coney dampers, and revised bushings. The changes didn't eliminate oversteer, but they made the transitions more progressive, giving drivers more warning before the rear stepped out. Meanwhile, Porsche's engineers continued working on the fundamental problem. They understood that rear-engine physics created two primary challenges: reduced front-end grip during acceleration, and that violent weight transfer during deceleration or liftoff. For model year 1969, Porsche extended the wheelbase by 57 mm, moving the rear wheels backward. This subtle change improved stability by increasing the moment arm, the distance between the center of gravity and the rear contact patch. They also widened the rear track, giving the rear tires a broader stance for better cornering grip. The modifications cost money to implement, requiring new suspension mounting points and revised body panels. But Porsche committed the investment. Racing success accelerated. Vic Elford drove a 911T to victory in the 1968 Monte Carlo Rally, Porsche's first major rally win with the 911. The car defeated purpose-built competition from Lancia, Ford, and Alpine Renault. But Ferry Porsche still wasn't convinced the rear-engine layout represented Porsche's future. In 1970, he approved Project 928, a comprehensive program to develop a front-engine V8 Grand Tourer that would eventually replace the 911. The 928 project received significant resources. Tony Lapine led the design team, creating a smooth aerodynamic shape that looked nothing like the 911. Wolfgang Mobius engineered a water-cooled V8, a radical departure from Porsche's air-cooled tradition. Ferry's reasoning made business sense in 1970. American emissions regulations were tightening, and Porsche's air-cooled engines struggled to meet the new standards. Water cooling offered better temperature control, more consistent combustion, and cleaner emissions. The oil crisis of 1973 reinforced Ferry's concerns. Fuel economy suddenly mattered, and the 911's rear-engine layout with its heavy rotating assembly and air-cooled inefficiency looked increasingly outdated. Front-engine cars with water-cooled engines could meet emerging fuel economy standards more easily. Porsche's board authorized spending that exceeded the company's annual profits. The 928 wasn't just another model. It was supposed to be Porsche's future, the car that would carry the brand through the rest of the 20th century and beyond. Engineers relocated from 911 development to the 928 program. The company's best suspension specialists, aerodynamicists, and drivetrain engineers focused on creating a grand tourer that would handle like a sports car, while offering long-distance comfort the 911 couldn't match. The 928's design featured a rear transaxle, the gearbox mounted at the rear axle rather than behind the engine. This weight distribution trick put more mass over the rear wheels for traction, while keeping the center of gravity between the axles for balanced handling. Porsche achieved 49-51 front-to-rear weight distribution, nearly perfect by conventional engineering standards. The car used double wishbone suspension at all four corners, allowing precise control over wheel motion and geometry changes. Every design decision followed textbook sports car principles. Meanwhile, the 911 limped along with what Porsche management considered stopgap improvements. For model year 1972, they increased displacement to 2.4 liters, bringing power to 140 PS in the base model and 190 PS in the S variant. These weren't revolutionary changes, just incremental development to keep the 911 competitive until the 928 could replace it. Porsche scheduled the 911's phase-out for 1980, giving the 928 3 years to establish itself in the market. Ferry positioned the 928 as the sophisticated evolution of Porsche, grown up, refined, easier to live with daily. The 911 would continue for a few more years, serving enthusiasts who wanted the raw, involving experience, but the mainstream customer would choose the 928's civility. Porsche's management expected the 911 to be phased out by the mid-1970s, replaced by the more modern, practical front-engine design. The rear-engine experiment would end, and Porsche would finally build cars the way conventional engineering wisdom said they should. Except the market had other ideas. When the 928 launched in 1977, it won awards, European Car of the Year among them. Automotive journalists praised its performance, handling balance, and luxurious interior. But 911 sales didn't decline. Instead, they accelerated. Porsche sold 13,500 units of the 911 in 1977, more than double the 928's first-year sales of 5,300 units. Customers saw the two cars as completely different propositions. The 928 was impressive, but it felt like any high-end Grand Tourer, smooth, fast, comfortable. The 911 felt like nothing else on the road. That rear-engine layout created a driving experience that front-engine cars couldn't replicate. The sensation of acceleration pushing you forward while the rear wheels clawed for traction, the weight shift during braking that compressed the front suspension, the requirement to think ahead and commit to your line, this was what Porsche buyers wanted. Racing results reinforced the 911's unique character. Porsche prepared the 911 Carrera RSR for motorsport, winning the 1973 IMSA GT Championship and numerous victories in the Trans Am series. The track's success came from exploiting the rear-engine layout's advantages, exceptional traction during acceleration, out of corners, stable braking with all that rear weight helping anchor the car, and the ability to carry momentum through fast sweepers. Porsche's engineers learned to work with the physics rather than fighting them. For the 1974 Carrera 2.7 RS, they developed a distinctive rear spoiler, the ducktail, that generated downforce specifically over the rear axle, increasing grip where the car needed it most. The turbo model, introduced in 1975 as the 930, took the rear engine concept to its logical extreme. Porsche added a turbocharger to the 3-liter flat six, producing 260 PS and massive torque that overwhelmed the rear tires without careful throttle application. The 930 Turbo became legendary for its challenging nature. The turbocharged engine's power delivery came in a rush above 4,000 revolutions per minute, and if that boost hit mid-corner with the wheels already near the limit, the result was spectacular oversteer. Porsche's turbocharger technology came directly from their Can-Am racing program. The 91730 Can-Am car had used a turbocharged flat 12, producing over 1,100 PS, teaching engineers how to manage boost pressure, reduce turbo lag, and handle the thermal stress that forced induction created. Adapting this race technology for a street car presented unique challenges. The 930 needed to idle smoothly in traffic, operate reliably in all weather conditions, and meet emissions regulations, requirements that didn't exist in racing. Porsche used a single KKK turbocharger mounted above the engine, drawing exhaust gases from both cylinder banks. The turbo spooled slowly by modern standards, creating noticeable lag. Press the throttle, wait a moment, then feel the boost slam you back in the seat as the turbine reached operating speed. This lag made the 930 even more challenging to drive fast. You needed to anticipate when boost would arrive, judging corner exit speed and throttle position, so the power came on when the car could handle it. Get it wrong, and that sudden surge would break traction mid-quarter, with consequences that arrived faster than most drivers could react. Porsche widened the 930's rear track and added massive flared fenders to accommodate wider tires. The rear wheels measured 8 inches wide, enormous for 1975, wearing 225 section tires that still weren't enough to contain the torque in first and second gears. The distinctive whale-tail rear spoiler became the 930's signature visual element. This massive wing generated significant downforce over the rear axle, helping press those wide tires into the pavement. But it also announced the car's presence from 100 meters away. Subtle, the 930 Turbo was not. Inside, Porsche fitted leather and air conditioning as standard equipment, positioning the Turbo as a luxury GT despite its raw performance character. The cabin featured the same basic dashboard as lesser 911s, but with a boost pressure gauge replacing the clock, a constant reminder that this car operated on different principles. Automotive journalists called it the Widowmaker, but buyers lined up anyway. Porsche couldn't build 930 turbos fast enough to meet demand, even at prices exceeding 65,000 Deutschmarks, nearly double the standard 911's cost. The Turbo proved that Porsche had built an entire brand identity around the rear engine layout's unique characteristics. Owning a 911 Turbo meant joining an exclusive club of drivers who'd mastered one of the world's most demanding road cars. By 1980, the situation was clear. The temporary 911 outsold the future 928 by 2-1. Thierry Porsche acknowledged what the market had been telling him. The rear engine layout wasn't a compromise to be tolerated. It was the foundation of Porsche's identity. Porsche kept both cars in production, but development resources shifted decisively toward the 911. The engineers who'd spent 15 years trying to manage rear-engine physics now focused on perfecting it. The next breakthrough came with all-wheel drive. Porsche developed the 959 supercar in the mid-1980s, using a sophisticated computer-controlled AWD system that sent torque to the front wheels when sensors detected rear slip. The 959 system proved the concept, and Porsche adapted it for the production 911 Carrera 4 in 1989. Now the front wheels could help during acceleration, using some of that rear weight bias constructively rather than just fighting it during corners. Suspension evolution continued relentlessly. For the 964 generation in 1989, Porsche introduced coil springs replacing the previous torsion bars. Semi-trailing arms gave way to a multi-link rear suspension with 5 separate control arms per wheel. This new rear suspension allowed engineers to tune camber, toe, and compliance characteristics independently. They could program exactly how the rear wheels would respond to different inputs: braking, acceleration, cornering forces, minimizing the violent transitions that had plagued earlier 911s. The 5-link rear suspension, technically called the Weissach axle, after Porsche's development center, represented a breakthrough in rear-engine packaging. Each rear wheel connected to the chassis through 5 individual links, 2 longitudinal arms, 2 lateral arms, and 1 diagonal arm. These 5 links created a geometrically defined wheel path that Porsche could precisely control. When the car accelerated hard, the suspension geometry automatically adjusted toe angles to prevent the rear from getting squirrely. Under braking, the geometry changed again to maximize stability. The system worked passively. No electronics, just clever mechanical design that used suspension loads to trigger beneficial geometry changes. Porsche had essentially programmed mechanical intelligence into the suspension, making the car self-correct behaviors that previously required driver intervention. The 964 also introduced power steering for the first time in 911 history, controversial among purists who had always valued the unassisted steering's feedback. but the addition reflected Porsche's commitment to accessibility. Power steering made low-speed maneuvering easier without significantly compromising the connection between road and driver. Porsche's engineers spent 2 years calibrating the power steering system. They tested different assist curves, varying how much help the system provided at different speeds. The final calibration gave significant assistance during parking, but reduced help progressively as speed increased, maintaining feel during spirited driving. The 964 Carrera 2 and Carrera 4 models launched simultaneously, offering rear-wheel drive and all-wheel drive variants. The Carrera 4's AWD system used a computer-controlled center differential that could vary torque distribution based on wheel slip and throttle position. Under normal driving, the system sent 31% of torque to the front wheels and 69% to the rear, maintaining the rear-biased character that defined 911 driving dynamics. When rear slip exceeded programmed thresholds, the system could send up to 50% forward, using the front wheels to pull the car through corners where the rear would otherwise step out. This represented Porsche's first acknowledgement that electronics could help manage rear-engine physics without diluting the driving experience. The Carrera 4 proved faster on wet roads and more confidence, inspiring for average drivers, all while retaining the distinctive 911 feel that required technique and rewarded skill. Electronic aids arrived with the 993 generation in 1994. Porsche Stability Management used wheel speed sensors, yaw sensors, and steering angle inputs to detect when the car began rotating beyond the driver's intentions. The system could reduce engine power and apply individual wheel brakes to counter oversteer, essentially using technology to mask the physics that created the problem. Purists complained, but the 993 became the most accessible 911 yet, expanding the customer base to include drivers who'd been intimidated by previous generations. The 996 in 1999 brought water cooling and more refined suspension geometry. Porsche's engineers, now with 4 decades of rear-engine expertise, created a car that handled with mere neutral balance despite still carrying 62% of its weight over the rear axle. Each generation built on lessons learned from millions of kilometers of testing, racing feedback, and customer input. Porsche turned rear-engine handling from a liability into a carefully managed characteristic that delivered unique driving dynamics without punishing normal drivers. The question remains, what would a front-engine 911 actually drive like? Porsche provided part of the answer themselves with the 928, 944, and 968 models that ran alongside the 911 through the 1980s and 1990s. These front-engine Porsches handled predictably, with balanced weight distribution that made them easy to drive fast. The 928 GTS with its 350 PS V8 could lap the Nürburgring Nordschleife faster than many contemporary 911s, using sheer power and excellent chassis balance. But they never captured the 911's magic. Driving a 928 felt scientific, methodical. You calculated the apex, turned in, applied power, exited. It was efficient and rewarding in an intellectual way. Driving a 911 felt visceral. You sensed that rear weight through the steering wheel, felt the rear suspension compressing under acceleration, learned to use throttle position to adjust your line mid-corner. The car communicated constantly through vibrations, sounds, and the way weight shifted. Front-engine competitors confirmed this difference. The Corvette, Ferrari's front-engine V12 models, even BMW's M cars handled with more predictable balance, but less character. They were faster, often objectively better, but they didn't require the same dialogue between driver and machine. Porsche's competitors tried to copy the 911's formula and discovered why it remained unique. Alpine built rear-engine sports cars through the 1970s, but their handling reputation scared away customers. Renault experimented with rear-engine layouts in racing, achieving success, but determining the concept too risky for road cars. Only Porsche persisted. Only Porsche accumulated enough engineering knowledge to make the layout work. By the 1990s, they'd turned decades of problem-solving into a competitive moat. No other manufacturer had the expertise to develop a rear-engine sports car that didn't kill its drivers. BMW tried to challenge the 911's market position with the Z8 Roadster in 1999, featuring a front-mounted V8 producing 400 PS. The car looked beautiful, drove wonderfully with balanced handling from its 50-50 weight distribution, and failed commercially. BMW produced just 5,703 units before discontinuing it in 2003. The Z8 failed because it competed on dimensions where luxury sports cars were already crowded: power, refinement, prestige. It offered no unique experience, no reason to choose it over a Porsche or Mercedes or Jaguar, beyond subjective aesthetic preferences. Mercedes-Benz's SL class represented another conventional approach. The R230 generation launched in 2001 with a retractable hardtop and front-engine V8 or V12 powertrains. Mercedes sold nearly 260,000 units over 11 years, commercial success by any measure, but the SL never threatened the 911's enthusiast following. SL buyers wanted comfort and prestige. They appreciated the car's refinement, its ability to cross continents at high speed without drama, the three-pointed star on the hood. The 911 attracted different people, those who wanted challenge, engagement, a car that rewarded skill development. Chevrolet studied the 911 intensively when developing the C5 Corvette in the late 1990s. GM engineers analyzed how Porsche managed rear weight bias, how the suspension geometry adapted to different driving conditions, how the car communicated its limits to drivers. The C5 Corvette that emerged in 1997 was brilliant, powerful, capable, affordable at less than half the 911's price. But it drove completely differently, with balanced handling that made it easier to drive fast, but less distinctive, less memorable, less engaging for enthusiasts who'd learned the 911's language. Even Ferrari, with vastly more racing heritage and exotic brand cash, couldn't replicate what the 911 represented. The 360 Modena and its successors offered mid-engine exotic performance, but they served different purposes: weekend toys, statement pieces, dream cars. The 911 was different. You could daily drive one, take it to track days, use it for business meetings, then push it hard on mountain roads Sunday morning. This versatility came from 60 years of refinement, focused on a single layout, learning to balance the extremes rather than avoiding them. Japanese manufacturers watched from a distance. Honda built the NSX with mid-engine layout and aluminum construction, creating an excellent sports car that was easier to drive fast than any 911. But it lacked character, lacked the sense of dialogue between driver and machine that rear-engine physics created. Toyota attempted a front-engine sports car with the Supra, then another with the 2000 GT decades earlier. Both were technically impressive. Both failed to capture enthusiast imagination the way the 911 did. They lacked the mythology, the accumulated stories of owners learning to manage oversteer, the racing heritage, the sense of mastering something difficult. The business implications became clear. Porsche's commitment to the rear-engine layout created product differentiation that competitors couldn't replicate without decades of investment. Every 911 successor had to maintain rear-engine packaging, forcing continuous innovation in suspension design, electronics, and aerodynamics. This created a virtuous cycle. Each generation's engineering advances justified premium pricing. The 911 Turbo consistently commanded prices double or triple those of front-engine competitors with similar performance. Customers paid these premiums because they understood they were buying accumulated knowledge, 60 years of engineering refinement focused on a single challenging problem. You couldn't get that experience in a Corvette or a Ferrari 550 Maranello or a Mercedes SL. The rear-engine layout also delivered unexpected advantages in packaging. That empty front trunk, Porsche called it a frunk, provided 125 liters of luggage space, where other sports cars had engines and all their ancillary systems. The rear-mounted flat six created a low center of gravity that helped handling despite the rearward weight bias. Air cooling maintained through the 993 generation eliminated radiators and coolant plumbing from the front, reducing weight and complexity. Racing continued, proving the layout's merits under extreme conditions. Porsche prepared the 911 GT1 for endurance racing in the mid-1990s, stretching the road car's design into a mid-engine configuration, but maintaining the rear-biased weight distribution that gave Porsche advantages under acceleration. The GT1 won the 24 Hours of Le Mans in 1998, validating decades of rear-engine development. Porsche's engineers had learned to extract every possible advantage from the layout, while minimizing the disadvantages through brilliant suspension geometry and aerodynamics. The GT1 program revealed something crucial about Porsche's institutional knowledge. When engineers designed the car's suspension, they didn't start from scratch. They applied lessons learned from 35 years of managing rear-weight-biased physics. They knew exactly how to tune anti-roll bars to prevent the car from becoming too nervous over curbs. They understood which bushing compliance characteristics would give drivers confidence during trail braking. They'd cataloged how different tire compounds interacted with rear weight transfer during acceleration. This accumulated wisdom created a competitive advantage that couldn't be copied. Ferrari and Mercedes built GT1 cars for Le Mans with superior budgets and more powerful engines, but Porsche's suspension tuning gave them an edge in the critical slow corners where races are often decided. The 1998 Le Mans victory came after a nail-biting final stint. The leading Toyota suffered a mechanical failure with just 60 minutes remaining, handing victory to the Porsche GT1, driven by Laurent Aiello, Alan McNish, and Stefan Ortelli. That win connected directly back to Butzi's decision in 1963. The GT1 might have been technically mid-engine, but its development relied on suspension knowledge, weight transfer understanding, and aerodynamic solutions that only existed because Porsche had spent 35 years solving rear-engine problems. Porsche's racing success extended beyond Le Mans. The 911 GT3 Cup became the backbone of one-make racing series worldwide, with over 4,000 examples sold since the first Cup car debuted in 1998, based on the 996 generation. These racing programs served as massive development laboratories. Every weekend, dozens of 911s competed in harsh conditions, full throttle for extended periods, hard braking, repeatedly heating components to extreme temperatures, suspension components, enduring constant loads over curbs and through high-speed compressions. Feedback from professional drivers and team engineers filtered back to Porsche's development center. If a suspension component failed in racing, engineers analyzed why and improved the design for both race and road cars. If drivers reported handling quirks at specific tracks, engineers investigated and developed solutions. This racing-to-road development loop accelerated the 911's evolution. Problems that might take years to discover through normal road testing appeared immediately in competition, giving Porsche rapid feedback on design decisions and component choices. Customer loyalty cemented the rear-engine layout's place in Porsche's future. By the 2000s, Porsche had built 650,000 units of the 911, and many owners upgraded through multiple generations, each time choosing the challenging rear-engine car over easier alternatives. These customers formed the core of Porsche's brand identity. They attended Porsche Club events, participated in track days, debated suspension settings and tire pressures with the fervor of engineers. The 911's demanding nature created a community that bonded over shared experiences and accumulated knowledge. Porsche Club of America chapters organized driving events where experienced 911 owners would coach newcomers through the car's unique characteristics. These informal training sessions transferred knowledge that couldn't be taught in manuals: when to feel weight transfer through the steering, how to recognize the moment before the rear stepped out, which throttle positions worked for different corner types. This community became self-perpetuating. New 911 owners joined the clubs, learned from veterans, then passed knowledge to the next generation. The car's challenging nature that could have been a market liability instead created tribal knowledge and belonging that strengthened the brand loyalty. The emotional attachment ran deeper than typical car ownership. 911 owners personalized their cars with specific option combinations, tracked their vehicle identification numbers, maintained detailed service records. Some owners kept their 911s for decades, accumulating hundreds of thousands of kilometers while refusing to sell, despite offers above market value. This loyalty proved invaluable during Porsche's darkest period. The early 1990s brought financial crisis. The company lost money in fiscal 1992 for the first time since becoming independent. Porsche's model range had grown bloated and expensive to produce, while recession reduced demand for luxury sports cars. Porsche recognized this loyalty as irreplaceable. When the company nearly died in the early 1990s, losing $150 million in fiscal 1992, the 911 became the lifeline. New management under Wendelin Wiedeking focused resources on the 993 development, betting the company's survival on the rear-engine car. The bet paid off. The 993 sold successfully enough to stabilize Porsche's finances, and the subsequent 996 brought huge sales increases as water cooling and modern production methods reduced costs while improving quality. By the 2000s, Porsche produced more than 30,000 911s annually, generating profit margins that made the company one of the most profitable automakers per unit sold. The rear-engine layout, initially seen as a compromised decision, had become the foundation of a business model that printed money. Each 911 generated higher profit margins than mass-market sports cars because customers paid premiums for the accumulated engineering expertise. The Carrera S commanded prices above $100,000, the Turbo S exceeded $200,000, and limited editions like the GT3 RS sold for even more, often with buyers paying above sticker price for allocation. This pricing power existed because Porsche had created something genuinely unreplicable. Competitors could match acceleration times, could design beautiful exteriors, could offer luxury interiors, but they couldn't offer 60 years of rear-engine suspension development, couldn't provide the unique driving character that came from physics rather than programming. The options list became another profit center. Porsche offered dozens of personalization choices, paint-to-sample colors, specialized interior leathers, carbon fiber trim packages, ceramic composite brakes, sport exhaust systems. Customers routinely specified $30,000 or more in options, and Porsche's production system could accommodate these custom orders without significantly disrupting efficiency. This mass customization capability developed from decades of experience building 911s to individual specification. Porsche learned to manage complexity that would overwhelm other manufacturers, treating each car as a semi-custom build while maintaining production volumes that kept costs manageable. The modern 911 demonstrates just how far Porsche refined the rear-engine concept. The 992 generation launched in 2019 with wide rear track, sophisticated electronic suspension control, rear-wheel steering, and decade of aerodynamic development focused on managing airflow over that rear-heavy mass. Porsche's engineers programmed the rear-wheel steering to turn slightly in the same direction as the fronts during high-speed cornering, effectively lengthening the wheelbase for stability. At low speeds, the rear wheels turn opposite the fronts, reducing turning radius and making the car more agile in parking lots. The stability control system runs on algorithms refined through millions of data points, detecting incipient oversteer microseconds before a human could react, and intervening so smoothly that most drivers never realize the electronics just save them from spinning. And yet, switch everything to Sport Plus mode, and the 911 still drives like a rear-engine car. That distinctive feeling of the rear end pushing through corners, the sensation of throttle steering, the way weight shifts during braking. Porsche maintained these characteristics even as they added systems to make the car safe for normal drivers. Performance numbers validate the engineering obsession. The 992 Turbo S produces 650 PS from a twin-turbocharged flat 6, accelerates from 0 to 100 km per hour in 2.7 seconds, and laps the Nürburgring Nordschleife in under 7 minutes, faster than most dedicated race cars from the 1990s. These numbers come directly from the rear-engine layout's advantages. exceptional traction during acceleration as weight transfers onto the rear tires, stable platform during hard braking, and the ability to carry momentum through fast corners using the mass as an anchor. Compare this to front-engine competitors, and the difference becomes obvious. The Mercedes-AMG GT produces similar power from its front-mounted V8, but it can't match the 911 Turbo S's acceleration times because the front tires have less weight over them during launch. The Chevrolet Corvette C8 moved to mid-engine layout in 2020, partially because GM's engineers recognized that front-engine architecture couldn't compete with the 911's launch performance. Even America's sports car conceded this battle to Porsche's 60-year-old layout choice. The financial impact of maintaining the rear-engine layout extends beyond just 911 sales. Porsche's SUVs, the Cayenne and Macan, fund research that benefits the 911, while the 911's engineering advances filter down to those SUVs' handling dynamics and electronic systems. Porsche sold over 80,000 units of the 911 in 2022, generating enormous revenue at premium prices. The GT3 variant alone, priced above $170,000, had waiting lists, stretching years into the future, with some customers paying over sticker price to secure allocation. This pricing power exists because no competitor offers the same experience. You can buy faster cars, more luxurious cars, more practical cars, but you can't buy another rear-engine sports car with 6 decades of engineering refinement behind it. The alternate history haunts automotive enthusiasts. What if Butzi had listened to his father in 1963? What if Porsche had committed to front-engine design from the beginning? The company would likely have succeeded. Ferry Porsche was a brilliant engineer and businessman. He would have developed an excellent front-engine sports car, competed effectively against Mercedes and BMW, maybe created something as respected as the BMW M cars or Mercedes SL class. The Porsche wouldn't be Porsche. The brand identity built around the 911's unique character, the customer loyalty generated by mastering a challenging car, the engineering reputation earned from making an impossible layout work. None of this would exist. Porsche would be another premium manufacturer, successful and respected, but not truly differentiated. They'd compete on power, luxury, brand heritage, the same dimensions as every other sports car maker. Instead, they compete on uniqueness. The 911 is the only rear-engine sports car still in production, the only car where 60 years of continuous development focused on solving a single challenging problem. This obsession with perfecting the rear-engine layout gave Porsche something more valuable than just a car. It gave them an identity that can't be copied or bought. Competitors can hire engineers, build factories, design beautiful bodies, but they can't replicate 60 years of learning. Racing heritage reinforces this distinction. Porsche won the 24 Hours of Le Mans 19 times, many victories coming from cars that used variations of the rear engine or rear-biased layout. The engineering knowledge from these racing programs fed directly back to road cars. The 911 GT3 RS, launched in 2022, uses suspension geometry and aerodynamics derived directly from Porsche's GT racing programs. The car laps the Nürburgring Nordschleife faster than many pure race cars, yet remains street-legal, civilized enough for daily driving if you're slightly crazy. This versatility, the ability to be both race car and daily driver, comes from decades of balancing the rear-engine layout's extremes. Porsche learned to tune the car so it's docile in traffic, but transforms into something savage when pushed, all while maintaining the unique character that makes a 911 feel like a 911. The electrification challenge tests whether this identity can survive into the future. Porsche launched the Taycan, their first fully electric car, in 2019, with a low-mounted battery pack that completely changes weight distribution possibilities. The Taycan handles brilliantly, with near-perfect weight distribution and instant torque that makes it faster in straight-line acceleration than any 911. But it doesn't feel like a Porsche in the way that matters to enthusiasts. Porsche promises to keep the 911 with internal combustion as long as regulations allow, recognizing that electric powertrains can't replicate the rear-engine character that defines their brand. The company is even developing synthetic fuels that would allow combustion engines to continue with reduced emissions. This commitment reflects understanding of what makes the 911 valuable. It's not just about speed or luxury or even prestige. It's about offering an experience that's genuinely different, that requires skill and delivers engagement in ways that physics dictates rather than engineers programming. The modern automotive landscape proves how rare this has become. Most sports cars now feel similar: fast, capable, electronically managed. Turn the stability control off in a Corvette, a BMW M4, or an Audi RS5, and they behave similarly with balanced handling that rewards smooth inputs. Turn off the stability control in the 911, and it still drives like a rear-engine car. You can feel that mass behind you, sense the pendulum wanting to swing, learn to use throttle position to rotate the car or settle it down. The physics haven't changed, just Porsche's ability to manage them. This difference justifies the 911's continued existence and success. In a world where most cars are optimized for maximum capability with minimum skill requirement, the 911 offers the opposite: a car that rewards skill development, that reveals more performance as you learn its language. Porsche's customer base understands this. They pay premium prices not just for performance numbers, but for the journey of learning to drive the car properly. The 911 owners' forums are filled with discussions about technique, suspension settings, tire choices, evidence of ongoing engagement rather than just ownership. The financial success validates the entire 60-year experiment. Porsche AG is worth over $75 billion as of 2023, much of that value built on the 911's reputation and the engineering expertise developed around the rear engine layout. The company now sells more SUVs than sports cars, but the 911 remains the halo that makes everything else credible. People buy Cayennes because they trust the company that makes the 911, believing that engineering obsession filters through the entire product range. And Porsche continues refining the rear-engine concept. The engineers who currently work on 911 suspension development have access to 60 years of documented testing, simulation data from millions of virtual laps, and feedback from thousands of track days and racing programs. They're still finding improvements. The 992 generation suspension calibration differs from the 991 before it in ways that seem minor on paper: revised bushing compliance, altered damper valving, modified toe angles, but transform how the car behaves at the limit. These refinements come from understanding gained through decades of focusing on a single problem. Porsche's competitors change directions, chase trends, develop new platforms every few years. Porsche evolves the 911 continuously, each generation building on lessons from the previous 60 years. This creates an institutional knowledge advantage that's almost impossible to overcome. Mercedes-Benz tried to challenge the 911 with the SLS-AMG and then the AMG GT, both excellent cars with front-engine layouts. Neither captured the 911's market share or commanded similar pricing power. Ferrari's front-engine Grand Tours, the 812 Superfast and its predecessors, offer more power and arguably more prestige, but they're different products serving different purposes. They don't compete directly with the 911 because they can't offer the same daily usability combined with track capability. The mid-engine Ferrari 296 GTB and F8 Tributo come closer to the 911's territory, but they're more expensive, less practical, and still don't have 60 years of rear-engine expertise behind them. They're spectacular machines, just different ones. So we return to Butzi Porsche's decision in 1963. The 28-year-old designer who insisted on hanging the engine behind the rear axle changed automotive history, not by being right about physics, but by being stubborn about identity. He understood that Porsche needed to be instantly recognizable, that the company's small size meant they couldn't compete on every dimension. They needed a niche, a specialty, a reason for customers to choose them over larger manufacturers with more resources. The rear-engine layout became that differentiation. It forced Porsche to become suspension specialists, to develop electronics earlier than competitors, to understand weight transfer and dynamic behavior at levels that wouldn't matter with balanced weight distribution. This specialization created a sustainable competitive advantage. Every generation of 911 is harder for competitors to match because it incorporates more accumulated knowledge. The learning curve doesn't flatten, it compounds. What looks like stubbornness from the outside is actually strategic clarity. Porsche chose their battlefield 60 years ago and committed to mastering it completely. They didn't chase after every new trend or try to be everything to everyone. Instead, they became the undisputed best at one specific thing, making rear-engine sports cars that deliver unique driving experiences while remaining usable, reliable, and safe enough for normal customers. This focus transformed an engineering compromise into a luxury brand's foundation. The rear-engine layout's challenges became the features that justified premium pricing. The learning curve became the barrier to entry that protected Porsche's market position. And the customers who bought into this philosophy became brand ambassadors, evangelizing about the 911's unique character to anyone who'd listen, forming clubs and communities, creating a culture around the car that no marketing budget could buy. The modern 911 exists as proof that Butzi was right, not about physics or safety or conventional engineering wisdom, but about brand identity and product differentiation. He was right that being unique matters more than being perfect. If Porsche had moved the engine forward in 1963, they have built a good car, maybe a great car, but it would have competed directly against Mercedes, BMW, Jaguar, Chevrolet, established players with their own engineering traditions and brand identities. Instead, they built the 911 and created a category of one. They established Porsche as the company that does things differently, that values character over convenience, that asks customers to meet them halfway rather than making everything easy. This philosophy attracted a specific type of buyer, someone who appreciated the journey as much as the destination, who wanted to learn rather than just consume, who saw mastering a challenging car as an achievement worth pursuing. These customers became Porsche's most valuable asset, more important than the factory in Zuffenhausen, or the engineering staff, or even the 911 itself. They form the community that made Porsche more than just a car company, that turned ownership into membership in something larger. The alternate history of a front-engine 911 is the history of a product without an identity, a sports car without soul, a company without a clear reason to exist beyond making nice things. The real history is the story of Butzi Porsche's stubbornness turning a flaw into a feature, a compromise into a philosophy, and a young designer's vision into 6 decades of automotive obsession. The 911 shouldn't exist, not with its engine hanging behind the rear axle like a physics problem waiting to manifest. But it does exist, and it's better, more interesting, more engaging, more valuable, precisely because of that wrong decision made in 1963. Porsche turned engineering's most beautiful mistake into a billion-dollar identity, proving that sometimes the wrong answer to the obvious question creates better results than the right answer ever could. And that's the secret Butzi Porsche understood 60 years ago. Perfection is forgettable, but character is priceless.